So as I was saying, since in step 5 we produce 2 molecules of glyceride 3-phosphate, it means that from step 6 to step 10, everything that you see will be what? Times 2. Everything that you see will be times 2. You understand? So let's look at something here. Maybe you understand it better here. So from step 6 to what? Step 10, where we will produce pyruvate, everything will be happening what? 2 times. So when you get NADH, multiply it by 2, making 2 NADH. When you get 2 ATP from 1 molecule of glyceride 3-phosphate, multiply it by 2, you will get what? 4 ATP. Hope you understand. Yes. So everything that will be happening will be times 2. Put that in mind. So let's move to what? Step 6. In step 6, the first thing that is going to happen is that the glyceride 3-phosphate will be converted to what? 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate. And that step is very important because in that step we will produce NADH. NADH in that step. In that step we produce what? NADH. Put that in mind. So that step is very important. Let's go here and look at something here. So we produce what? NADH, and we will multiply it by 2, making 2 what? NADH. And in that step, there are 3 things happening. You can see that in step 6, let's look at something here. In step 6, there is an addition of what? Phosphate. Because we were having only 1 phosphate, which is glyceride 3-phosphate. But now we are having 1,3-bisphosphoglycerate. So now we have 2 what? Phosphate. So there is an addition of what? Phosphate. And also there is removal of what? There is removal of hydride. There is removal of hydride. And this hydride will be given to what? NAD+. And this NAD+, when it gains the hydride, it will be converted to what? The NADH. Hope you understand. So there is what? Oxidation, which leads to the production of what? NADH. Hope you understand. And there is also the formation of what? A high energy phosphorylated what? Compound called the 1,3-bisphosphoglycerate. Hope you understand. So now let's move to the 7th step. In the 7th step, the 1,3-bisphosphoglycerate will be converted to what? 3-phosphoglycerate. 3-phosphoglycerate. And the enzyme that will perform the 7th step, we call it phosphoglycerate kinase. Phosphoglycerate kinase. And you can see that in the 7th step, we are producing ATP. Can you see that? We are producing what? ATP in the 7th step. So put that in mind. So the payoff phase, I said that we are going to produce how many ATPs? 4. And now we are producing the first ATP. And note that everything is times 2. So meaning that we are producing 2 ATPs at the 7th step. And this 7th step that I'm talking about, is very important. It's very important because most of the times, steps that are being catalyzed by enzymes that ends with the name of kinase. For example, hexokinase, phosphofructokinase, like those enzymes, the steps that they catalyze are irreversible. But for the 7th step, the enzyme is called phosphoglycerate what? Kinase, alright. But the step is what? Reversible. Can you see that? The step is what? Reversible. Step 7 is what? Reversible. Let me go back and talk about step 6. This step 6 is being inhibited by two molecules, one called iodoacetate and the other one called acinate. So iodoacetate and what? Acinate inhibit step 6. Put that in mind. So they can inhibit the enzyme that catalyzes step 6. What is the enzyme that catalyzes step 6? The enzyme that catalyzes step 6 is called what? Glyceride 3-phosphate dehydrogenase. Glyceride 3-phosphate dehydrogenase. So iodoacetate and acinate can inhibit this enzyme. Put that in mind. Let's move to step 8. Step 8. At step 8, the 3-phosphoglycerate will be converted to what? 2-phosphoglycerate, meaning that the phosphate that was on the third carbon will be shifted to the second carbon. So we will get 2-phosphoglycerate in step 8. Put that in mind. Let's move to step 9. Step 9 is very important. Let's look at what happens in step 9. You can see that in step 9, the 2-phosphoglycerate is being converted to a high energy compound called phosphoenol pyruvate. The 2-phosphoglycerate is being converted to a high energy compound called phosphoenol pyruvate. And the enzyme that catalyzes step 9, or the enzyme that catalyze step 9, is called enolase. Remember that the enzyme that catalyzes step 8 is called phosphoglyceromutase. I didn't talk about that. The enzyme that catalyzes step 8 is called phosphoglyceromutase. It is the enzyme that converts the 3-phosphoglycerate to what? 2-phosphoglycerate. And in step 9, the enzyme is called enolase. It is converting the 2-phosphoglycerate to what? Phosphoenol pyruvate. And this enzyme called enolase is being inhibited by a molecule we call what? Fluoride. So step 9 is being inhibited by what? Fluoride. But the enzyme enolase requires magnesium or manganese to function. Without magnesium and manganese, the enzyme enolase can't function. Put that in mind. Let's move to step 10. In step 10, the phosphoenol pyruvate will be converted to what? Pyruvate. As you can see in this picture, the phosphoenol pyruvate will be converted to what? Pyruvate. Here, as you can see, it is being converted to what? Pyruvate. And remember that everything that is happening 2 times, so times 2. So we are getting 2 molecules of what? Pyruvate. And in the conversion of phosphoenol pyruvate to pyruvate, we also produce ATP. So remember that the first ATP that was being produced was in step 7. And the last ATP that is being produced is in step 10. And we are gaining how many ATPs? 2 ATPs. And remember that step 10-2 is what? Irreversible. As you can see that the arrow is coming only down. So step 1, step 3, step 10 are irreversible. And step 3 is the rate limiting step, as I said. So we will continue later.